Name of this reading is Value at Risk Methods. Now, before we get technical on how to calculate VAR and what are the advantages and disadvantages of different methods, let's first understand the practical usage of this concept. Let us say you're a fund manager and you have a total portfolio worth, let us say 1 million. And what you want to understand is that under extreme conditions, not necessarily extreme, but on a bad day, what is the maximum loss you can have? But this is for a single day. That means if something goes wrong on a day, based on how things have behaved in the past or due with different reasons, what is the maximum loss you can have? So you can calculate maybe a 5% value at risk. Now, how to calculate that? There are different methods, but let's say with some statistical analysis, you realize that 5% value at risk for one day is, let us say, $12,500. Now, the most important thing here is how do you interpret this number? So there are two interpretations. The first interpretation is that you are 95% confident, confident that your losses will not exceed 12,500 in a single day. This is very important because we calculate value at risk for different time periods. So currently we are calculating we are doing an example on single day VAR. So this is the first interpretation. Or second interpretation is that there is a 5% chance. There is a 5% chance that portfolio losses will be 12,500 or more. And again, what it is telling us is that 95% chance the portfolio losses are not going to be more than 12,500. That's the maximum loss, value at risk. But there is a 5% chance that the losses could be more than 12,500. Now, if you remember when we were learning stress testing, we discussed about one disadvantage of VAR. And that disadvantage of VAR was in this sentence or this word here. So it tells us that there is a 5% chance that your losses would be more than 12,500 or more, but it does not tell us up to what limit those losses could go. Are we fine with this concept? This is called as value at risk. You can write down this quickly. So at times they also use, if they ask you a question just on interpretation, typically in the first sentence, they use the word maximum. In the second sentence, they use the word minimum. So on the exam, you might see a sentence which would say, you are 95% confident that your maximum losses would be 12,500. Correct, incorrect? Correct. Your 5%, there is a 5% chance that your minimum losses would be 12,500. Again, it is a correct sentence. So just be careful with these words. So what do we learn in this topic? First, we would look at the different versions of VAR definitions. Then VAR calculations using different methodologies. Then conversion of VAR. Is it possible to convert a 1 day VAR to a 1 week VAR or a 1 week VAR to a 1 year VAR? Or is it also possible to convert a 10% VAR to a 5% VAR or vice versa? So converting different time periods and also converting different confidence levels. Then we would look at different ways of calculation of those VARs. So one particular way is linear valuation, which is called delta normal valuation method. And the other one is full valuation, which will include two subtypes, which would be Monte Carlo and historical simulation. So let's start with the first one, definition of VAR. VAR is the dollar or percentage loss in a portfolio that will be equaled or exceeded only X% of the time. So VAR could either be quoted in terms of percentage. So you might see a VAR which says 3% or minus 3%, meaning of which is that whatever is the value of your portfolio, you can lose 3% in the specified time. Or it could be quoted in dollar terms. So it could be quoted as maybe 15,000 USDs. Are you fine here? A 1%, 5% and 10% VAR would be denoted as VAR 1%, VAR 5%, VAR 10. And these would be specified in terms of whether they are daily VAR or monthly VAR or weekly VARs. A VAR 5% of 15,000 indicate that there is a 5% chance that on any given day portfolio will experience a loss of 15,000 or more, which means there is a 95% chance that on any given day portfolio will experience either a loss less than 15,000 or a gain. So both the sentences mean the same thing. Are we okay with this? So now we would look at the calculations. These are the three types of calculations that we would be looking at this reading. The first one is delta normal VAR, then historical simulations, and then Monte Carlo simulation. Now to fully appreciate delta normal VAR, we will have to first make sure that we are comfortable with the concept of standard normal distribution. So I'm sure standard normal distribution, we typically also call this as a Z or Z table. And what we know with standard normal distribution, that it is a perfectly symmetrical distribution. The mean of this distribution is same as median, which is same as mode of the distribution. And generally in case of standard normal distribution, that mean is defined as, tell me, the mean of standard normal is defined as 0. So mean is 0 and the standard deviation of this distribution is 1. Right? So on the right we will have plus 1, plus 2, plus 3. On the left minus 1, minus 2, minus 3. And almost 99.99% of the data would be between plus or minus 3 standard deviation. Generally the first standard deviation from the mean, this region, is 34% of the probability. That means if you take plus or minus 1 standard deviation, it would be 68%. This additional 1% will have 13% probability. These are approximate calculation. That means this is 47 on either side. So you have roughly 96% probability in plus and minus 2 standard deviation, and the last standard deviation will have about 3% of probability. Now when you're dealing with VAR, a value at risk, you're not concerned about the right hand side. Your primary concern is about the left hand side of the tail. So with value at risk, let us say if you want to calculate a 95% confidence level, so what you essentially want to do is you want to leave 5% on the left tail and you want to have 95% in the right tail. So the appropriate Z value, which of course is going to be negative, we can look up in the normal distribution table. And if you're looking at cumulative normal distribution table, then we will search for probability of 0.05, correct? And that will give you a negative Z value of this particular level. Are you following this? So let's go and look up those values. Okay, so we have cumulative Z table here. Now we will have to look it in an inverse fashion, where on the left hand side of the tail, if you're doing a 99%, that means 1% VAR. If you're doing a 99% confidence, that means you are at 1% VAR. So we are going to leave how much? 1%. That means 0.01. So search for probability of 0.01 here. This value and this value, correct? So this is minus 2.3. This should be 0, 1, 2 and 3. So then we can remember that for 1% VAR, the appropriate Z value is going to be minus 2.33. So write it down in your notes somewhere. Now let us say you want to do a 5% VAR. So now we have to look for 0.055% between these two values. So 1, 2, 3, 0, 1, 2, 3, 4, 5. So we can take 5% value as minus 1.65. 5% value is minus 1.65. And let's take a 10% VAR. Now search for 10% in the probability tables. Here? Correct. So that would be 1.2 and we can take 8. So minus 1.28. So now we have three values, minus 1.28, minus 1.65 and minus 2.33. Now let's make use of this and let's understand how it works. Let us say portfolio value is 100,000. Average expected return of your portfolio are 10%, but with a standard deviation of 8%. So on an average, expected return are 10, standard deviation 8. This is again, let us say, monthly data. So we are calculating a monthly VAR again. Now you have been asked to calculate a 5% monthly VAR. 5% monthly VAR. So how do you do it? First, you plot a graph, a simple normal distribution graph. Now, what is the mean of your normal distribution with an assumption that the returns follow normal distribution? The mean is 10%. Then if you go 1 standard deviation, 2 standard deviation, 3 standard deviation. 1 standard deviation is how much? 8. So this would be 18% return. 2 standard deviation, 26% return. 3 standard deviation would be 34% return. Are you following this? 1 standard deviation on this side, 2 standard deviations on this side, 3 standard deviations on this side. This would be 2% positive return. This would be minus 6%. This would be minus 14%. Now there are two ways in which I can ask you a question. Number one, I can ask you what is the probability of getting a return less than minus 6%. What is the probability of getting a return less than minus 6%? So then what will you do? You will say minus 6%, that means it is minus 2 standard deviation. So you would try to find out probability in this region. And then how will you find out? You just go look for minus 2, which let me clear and let's see how much is that. So minus 2 is coming out to be, is it visible here? 0.0228. So you would say probability of getting a return which is less than minus 6% is 0.02% or 2%, 2.28%. Are you following what I'm trying to say? Shraddha? So this region here, this shaded area has a probability of 2.28%. Okay. But now I'm asking you the other way around. Now I ask you that what is the probability, what is that return, what is that threshold? For example, for 2.28% we've got a threshold of 6%. So for 5% probability, what area, from what point the area will fall on the left hand side of the graph? The other way around. In this case, I gave you the return. I said minus 6%, what is the probability? What if I give you the probability and ask you the return? The other way around. Okay, so how will you do it then? So I'm clearing this. Okay, don't write, just observe. I'll give you sufficient time to write. This is your graph. Now the question that I've asked you is, what is the 5% value at risk? That means I want that point in this graph where on the left there should be a probability of 5% left. On the left there should be a probability of 5%. On the right there should be a probability of 95. So what you would do is you would do reverse calculation. In this table you would try to search for what is the Z value for 5% probability. That Z value we have already found out, which is minus 1.65. So this point here, which is minus 1.65. So on the left of this, we have a 5% probability, which means on the right of this, in this region, on this region here, we are going to have a 95% probability. Now, you have to find out what is the rate of return that is applicable for this minus 1.65 Z factor. For example, for minus 1 Z factor, the rate of return was 2%. For minus 2 Z factor, the rate of return was 6%. For minus 3 Z factor, which is here, for minus 3 Z factor, the rate of return was 14%. So what is the rate of return for minus 1.65 Z factor? And it's simple, it is simply minus 1.65 standard deviations away from the mean. So then how will you calculate that? You would say 10% is your mean minus 1.65 into what is the standard deviation? 8. How much is that? 3 point? Minus 3? Minus 3.2? That's it. So minus 3.2%. So then you would say that your 95% confidence or 5% monthly VaR is minus 3.2%, or if you want to convert that to amount, that would be US dollar 3,200. 100,000 into minus 3.2%. So you would say that 3,200 is your value at risk, 5% value at risk for 1 month. So in a month's time, there's a 5% chance that your losses will exceed beyond 3,200. There's a 95% chance that your losses will be less than 3,200, or you will have a profit. Let's do one more. See, it's not so difficult. Just get hang of the concept, you would feel very confident. Let us say you have a portfolio of 17 million US dollar. Okay. Your expected daily returns are 0.17%. And your daily standard deviation is 0.13%. You have to calculate a 10% daily VaR. 10% daily VaR. So this one again I will solve for you. Next one you can solve by yourself. So again you simply plot this on a normal distribution. And then if you want a 10% VaR, that means you want to leave 10% probability on the tail, and you want to have 90% probability in the right tail. So then for this, leaving this 10%, what is the appropriate Z value? How many standard deviations is it away from mean? We have already found it out. It is 1.28 standard deviation away from mean. What is the mean value? Mean value is 0.17%. So how much would be 1.28 standard deviation away, that would be 0.17 minus 1.28 into, make sure you do calculation in percentage here, into 0.13 percentage minus 0.0036%. That's your VAR in percentage. And if you want an amount, then multiply that with 17 million. So in dollars, that would be 61,200. So 61,200. Multiply 17 million into 0.036%. Is it 61,200? Yes. So how do you read this? That there is a 10% chance that your losses will exceed 61,200. That means there is a 90% chance that your losses will be less than, or you will have a profit. Your losses will be less than 61,200, or you will have a profit. Right tail includes profit as well, isn't it? There is some point which is zero somewhere here, zero returns. Somewhere between this. After that, to the right of it, we have profit. Are we good? He's asked a good question. We'll solve few questions like that. The question is asked, if the question does not specify returns, it just gives you standard deviation, then how do you solve? Then you assume returns to be 0 and then solve. First example, yes. But first example, but it wasn't completely correct because I should have plotted the value of asset on the distribution. Value of asset will follow a log normal distribution. The returns on the asset will follow a normal distribution. Asset cannot be less than, value of asset cannot be less than 0. Right? So asset follows log normal. The percentage return follows normal distribution. We would first look at delta normal VAR. What I want you to remember here is, of course, most important, it assumes normal distribution. Second, it captures only the linear risk exposures. So I have one formula here. Write down that formula for the timing. In the subsequent part of this reading, we will solve few numericals on this. And then, if you remember, that duration is a linear measure of risk. Okay, so here it is capturing only the duration. It is not capturing the second delta, which is convexity, in this particular formula. Are you done writing this? So same point. Calculating delta normal VAR requires assuming that asset returns conform to a standard normal distribution. Remember these critical values explicitly: 1.28, 1.65 and 2.33. First example. We have VAR of an asset which has daily standard deviation of 1.7. It has a current value of 15.25 million. Calculate VAR of 5% on both percentage and dollar basis. So here we just have the standard deviation, we do not have the returns. So again, this is your mega, this is your normal distribution. We want to calculate a 5% VAR. So we are looking at this particular point where on the left we have 5% probability, on the right we have 95%. The relevant Z factor here is minus 1.65 for 5%. Since your standard deviation is 1.7 and there is no return mentioned, so we would simply say minus 1.65 into 1.7. And how much is that? 2.805% negative. So this is the VAR in percentage term. If you want to convert that to amount, 15.25 million multiplied with 2.805% negative, that would give us an amount of 421,451. So this is your 5% VAR. Now of course, is it daily? For a daily VAR, it's a really large amount because your portfolio by itself is really large. Plus it seems to have a substantially higher standard deviation. 1.7% per day is quite large standard deviation. So what this is telling us is that on a single day, there's a 95% chance that your losses will be less than 421, 451, or you would have a gain. That means this region, losses less than that, or you will have a gain. And there's a 5% chance that your losses will exceed more than 421, 451. Are we good to go ahead? Example 2. So this time we are looking for 1% VAR. That means your Z value is going to be 2.33. Standard deviation is given as 2.1%. So this multiplied with 2.1% minus 0.89 percentage. And in terms of amount, it would be 10.25 million into minus 4.89 percentage. $501,532. Again, interpretation is there is a 1% chance, is it daily, that on a single day your losses will exceed beyond 501,532. There's a 99% chance that your losses will be less than 501,532, or you will have a profit. Now if nothing is mentioned, if they have not mentioned returns, we assumed 0 returns. So if I ask you what is the probability of making profit, it will be 50%, because 0 is your center. So probability of making profit 50%, probability of making losses 50%. Is that making sense? Example 3. Let's do it fast now. What is the Z value now? Z value minus 1.28, and this we will multiply with 1.1, that will be 1.408 percentage, and in amount it would be 9.45 into 1.408% negative, which is 13056 dollars. Should we go ahead now? Example 4, which is slightly different now. 2-week VAR or 10-day VAR is what the Basel II norms require. So now in this case, we have expected returns as well. So we want to calculate a 5% VAR. So 5% on left L, 95% on this side. Z value is 1.65 standard deviations away from the mean. Mean is given to us as 0.17%. So 0.17 minus 1.65 into the standard deviation 0.11. And in percentage term, that's how much? In percentage, 0.0115 percentage, and then in amount we would multiply that with 500 million, so that would be 575,440. This is your 57,540. This is your 5% value at risk for 2-week VAR. Are we good to go ahead? Example 5. Now it is not given in percentage. I mean, they are given absolute amounts. Not absolute, but it is 0.0014. No percentage sign there. So we would convert this to percentage. So 0. Or we don't need to actually. So this is your normal distribution. We need 10% VAR. What is the Z value? Minus 1.28 into, now in this case we have a return, so we'll actually have to solve for it. So your expected return are 0.0014 minus 1.28 into standard deviation 0.012, that will be 0.01396. So that's about 1.396 percentage, correct? And that you multiply with 200 million, and that will give you the amount 2792.123. So that's about 2.79 million. Are we 2792,000? Fine. Are we good to go ahead now? Alright, so now in this section we discussed how do you convert VaR from different frequency or different time horizon. So VaR can be converted from 1 day basis to a longer basis by multiplying the daily VaR by, this is your answer, square root of the number of days. So if you want to convert to a week, you will multiply by root 5. 5 working days in a week. So you will multiply with under root 5. If you want to convert that to a month, you would multiply with under root 20 or 22, number of working days in a month. If you are converting to a year, you would multiply with under root 250. Right? Just multiply with the under root value of equivalent to convert, and you would get the monthly or annual VaR. So we'll do a few examples. See, now we have a daily VaR of 17,000 and you have been asked to convert that to weekly. So how will you do weekly? You would say weekly VaR is equal to daily VaR 17,000 multiplied with under root 5, and monthly VaR here would be 17,000 multiplied with under root 20. Semi-annual you would multiply with under root 125, and if you want to convert that to an annual basis, so 17,000 here, 17,000 multiplied with 250. Are we okay? Now there is a small catch in this, that this conversion works very smooth if you assume that your returns were 0. So we learned that there were two ways of calculating VaR. One, when you have an expected return, and second, when you do not have an expected return. Correct? When you simply assume expected return to be 0. So this method works best when you have assumed expected return to be 0. If you've assumed expected return to be some value, then there are some potential problems with this methodology, okay, which you need not get into. Are we good to go ahead? Alright, so you try doing this. Try to get the amounts. Yes, done. Tell me, what is weekly VaR? 44050. And monthly? 8810. Okay. Now VaR can also be converted to different confidence level, and just remember that these are simple proportionate calculation. For example, let us say you have been given a 90% VaR at 10,000 and you have been asked to calculate a 95% VaR. So then how will you do it? What is the Z value for 90%? Z value for 90%, it was 1.28. So you would say for Z value of 1.28, your VaR is 10,000. How much would be your VaR for a Z value of 1.65? So 10,000 into 1.65 divided by 1.28, and that will get you the answer. Are you fine? Again, this will work best when you are assuming that expected returns are 0. If you are assuming expected return a non-zero value, again this analysis will not make complete sense. Are we good to go ahead? Let's practice a couple of examples. So now you would say 1.65 is 21,500. So 2.33 would be how much? 21,500 into 2.33 divided by 1.65. How much? 3036.0. Easy. So I have one more example, but we can skip that. Alright, so we're through with the delta normal VAR part now. Now we would look at the historical simulation. Now historical simulation is purely based on historical data. I want you to write down this particular sentence. Give heading historical simulation. Accumulate a number of past daily returns that rank the returns from highest to lowest and identify the lowest 5% returns. So it looks fancy, but again it's relatively easy concept to comprehend. Let us say we are looking at the returns earned by a fund manager for last 100 days. So we take his daily returns. So let us say on one day he earned 3%, minus 3, then plus 2%, plus 11%, plus 17, and so on and so forth. Now out of these, let us say you have been asked to calculate a 5% historically simulated VAR. Okay. So step number 1, you will have to order these returns from lowest to the highest sequence. So tell me which one out of these is lowest? Minus 6. Second lowest? Minus 3. Third lowest? Minus 2.5. Fourth lowest? Minus 1.5. Fifth lowest? No, let me add something. Minus 1% and minus 0.75%. Okay. Yeah, so the fifth one would be minus 1%, minus 0.75%, then 0. And this fashion you would keep on arranging them. Okay. Now 5% VAR means out of those 100 days, which the easiest way to think is, okay, of course this is loose language, but the easiest way to think, out of those 100 days, which ones were the worst 5 days? Because with VAR we are always looking at the left tail. So which ones were the worst 5 days? So this was 1, this was 2, this was 3, this was 4, this was 5. Out of those worst 5 days, you have to take the least worst. Right? So similar to building analogy with normal distribution, this entire area is the worst period, but it starts from here with this line, right, which is the best in the worst. So in the same fashion, out of these 5, the best in the worst is which one? This 1%. So on the left of this one, the negative returns start. So we can say using historical simulation with 5% VAR, value is 1%. That means there is a 5% chance that your returns would be or your losses would be more than negative 1%. That means 95% chance on the right hand side that your losses would be less than 1% or you will have profits. Just arrange the data and take the worst 5 and then take the best out of the worst 5. Are we easy with this? Now it makes sense because you're dealing with actual data. This is what has happened in last 100 days, and that these are the worst 5 scenarios, right? So 95% of the time you are on the right hand side, 5% of the time you are on the left hand side. So if the history is to repeat itself, then this is what will happen to the portfolio. If it was a 99%, okay, if it was a 90% VAR or 10% VAR, then we would have taken the 10th value. And if it was 99%, then we would take just the first value. Correct? 99% means we would just take 1%. That is one day you would have bad, And that one day which is bad in this case would simply turn out to be -6%, the worst day. Are you fine? Now instead of 100 days, if we had let us say 60 days data, then 5% VaR means worst 3 days. So worst 3 days would be 1, 2, 3, and then your out of worst, the best scenario is -2.5. So -2.5% will become your VaR. Are we doing good here?